Oh, of course, it can't be just, quite that simple. Within each type of reaction, there are like subtypes, I guess you could say. Just like, you look at your socks. Well, your socks are different from your underwear, but your socks are not all the same, are they? They're different types. There's dress socks, and there's sweat socks, and there's low-cut socks, and there's knee-high socks. So in the combination reactions, we're going to look at 3 different types of combination reactions. And the first one is a metal reacting with oxygen. When a metal reacts with oxygen, you get metal oxide. If the metal is a main group metal, we can predict the formula because we know what its charge is. If the metal involved is a transition element, one of those ones that needs a Roman numeral, we don't know which charge it's going to take, and so we cannot predict the formula just based on what the reactants are. We would have to have a lot more knowledge to do that. So this is the general form. A metal plus oxygen gas forms a metal oxide. And this fits that pattern of the combination reaction where you've got 2 reactants and only 1 product. The 1 product is the key. So an example is magnesium, which is a metal, reacting with oxygen. This involves some heat, and we get a metal oxide, magnesium oxide. We can predict this formula because magnesium forms a plus 2 charge. Yeah, I'm sorry, I just had a little brain fart there. Plus 2 charge, oxygen has a minus 2 charge. And then the equation is balanced because here we've got MgO, that would be 1 gray and 1 red, but oxygen comes in pairs. And so we need to double this so that we have 2 red ones. That gives us 2 gray ones, and so we need a 2 over here and to have 2 gray ones over there. So let's do a couple of examples, and then we'll call it a day. Write a balanced chemical equation for each of the following combination reactions. Now notice it's saying balanced chemical equation. The first time we wrote equations, we didn't balance them. Turns out they were balanced, but that's because they were chosen very carefully to be balanced without any coefficients. So lead metal. What is the symbol for lead? Pb. And if it's a metal, what is its state symbol? S. It's a solid. Is heated with oxygen. Okay, so plus O2. And oxygen is in what state at room temperature? A gas. We can look at the periodic table and see that oxygen's element symbol is in red. The red ones are gases at room temperature. But I think most of us recognize that oxygen is a gas. To yield. Okay, is heated with. We put the little triangle above this. To yield solid lead 4 oxide. Okay, well, lead 4 is lead 4 plus, and oxide is O2 minus. So this is a situation where we can get in trouble with crisscross. If we crisscross, we're going to get Pb2O4, aren't we? If we put this down here and that down there. Is that the lowest ratio? No. It should be PbO2. And it's a solid because they tell us that. Is this equation balanced? Yes, it is. Sometimes they are. We're generally thankful when that happens because then we don't have to mess with it. There's 1 lead here and 2 oxygens, and there's 1 lead and 2 oxygens. Let's do the next one. Potassium metal. Well, that would be K, solid, heated with oxygen. So that's O2, gas. Heated. I see stuff like that. Not apparently when I was typing it yesterday, but I see it now. Potassium oxide. Well, potassium has what charge? as an ion. Plus 1, and we already talked about oxide, K minus, so we need K2O, and they tell us it's a solid. Is this one balanced? No. Well, this is the most complicated one, so let's start here. Here we got 2 Ks, so we should put a 2 over here, right? And that would fix the potassiums. And then we look here, we've got 1 oxygen and 2 there. So we're going to have to put a 2 in front of the K2O, aren't we? To balance the oxygen. So now we've got 2 oxygens and 2 oxygens. But we screwed up the potassium. So how many potassiums do we have over here now? 4. So that's okay. We did this in pencil, and we can just erase that and put a 4 there. Any questions?